Friends, as part of this session, let us understand some other internal implementations of our string class. Okay, the first thing before I go and discuss that internal implementation, let me know one thing. Does a string is user defined data type or else a primitive data type? Observe here. Okay, what is that? Does a string is user defined data type? Does a string is user defined data type or primitive data type? Observe here, does a string is user defined data type or primitive? Getting? Observe here, what is user defined data type? First, let us understand primitive. Int I equals to double 9. I is a variable of primitive of data type int, getting, which is having or holding the value as 9. Okay, now I want to create user defined data type. Observe here, class A. Okay, now int A or else something int j equals to minus 9. Now observe here, at one of the other class within the main method, if I am written the statement as a equals to new a. Now what is a type? A is a reference variable, getting. Now small a is a variable of type capital A. This capital A is not at all available within our primitive data type hierarchy. Byte is the child for short and short is the child for int, and it is having one more child, a char, and it is what? Long. Float, a double, and other one is what? A boolean. It is entirely different from this primitive data type hierarchy. And you are having even the string also. The most of us will get confused at this. Okay, we'll discuss. Okay, so this is the primitive data types available within our Java programming language. Now observe here, this a is a reference variable. We can also spell this one as what? Reference variable. Strictly it is a variable of type capital A. A is what now? Is it available within primitive data type hierarchy of Java? Primitive data type hierarchy of Java? No. It is what? User defined data type. Observe here, this int is a variable of type this I is a variable of type int. Observe here, where is the int skeleton? Of course it is available within the, that is what and all the rules and principles which we have to follow as part of int data type is available within our JDK. Okay, like that. Now A is what? A data type. Its a skeleton, its principles, its rules are all available here. So now this class A is what? A user defined data type. Of course class is what? A blueprint, getting, but let us understand that one some more technically. Okay, now observe here, because of class keyword here, you are telling A as what? User defined data type, getting. So A is what? A is a variable of type user defined data type called capital A. So this one is what? User defined data type, and user defined data type will have class keyword. Now observe here, within the lang package of our java.lang, within the lang package we are having a class called a string, getting. Now tell me, it's having lots of implementation. Now string is a user defined data type or a primitive data type, getting. It is a user defined data type or primitive data type. Here this class A is this A is having skeleton. So that's why it is what? User defined data type. Now string is also having skeleton. Now string is user defined data type or a literal. Simple thing. Observe here. That's what we are discussing. Okay. Now if I write this statement, called a string s equals to a new string, let it be Mohandu, getting Mohandu, and if I write the statement as a string s equals to Mohandu. Observe these two statements, guys. A new keyword or an operator followed by string class constructor. Within the string class you are having a string constructor having argument as string literal, getting a string. Okay, now observe here, this is what, observe this one, it is what, directly a string literal. Here yes, and here yes is, observe here, within the class called a string, getting what is there, one string class constructor is there of type what, a string only, getting some implementation, getting. And now observe here, it's a final class, getting. Now to create a string object here, of course both the statements create a string object only, okay, but let us understand whether it's a user defined data type or primitive data type. Now observe here, within the primitive, that is user defined data type a skeleton, getting what is this, guys? Just now we have understood what it is, it's the skeleton. Okay, now here within this principle and rules, this is the specifications, right? Of course some of the few things will be acting as guidelines to us. Now to create a string object in this statement, I am using the constructor, getting. So now here you are using even new keyword also. Now here yes is purely user defined data type variable, getting, and what its type means, string, getting, and string is what, user defined data type, getting. You are using constructor of this skeleton, getting, and even class is available in front of a string keyword, so it's what, a user defined data type. Now observe here in this statement, what is this, guys? Int I equals to 99. I is a variable of int, that is int primitive data type. Now what is this double line? What is this double line? It is int value or a constant, getting, int value or a constant. You are directly writing double line. Why? Compiler and JVM is having knowledge, they are having predefined knowledge about this literal. The same thing, observe here. Okay, yes, string s equals to, within double quotation, one sequence of characters, getting. So it is having, compiler and JVM is having knowledge about this double quotations. Whatever you write the characters within this sequence of characters within this double quotations will be treated as by default string literal, getting. Whatever you write within the double quotations, getting, without any new keyword and without any string class constructor, it will be treating as a string primitive data type and primitive literal, getting. So this is what here, a string is what, primitive data type, getting, guys, it's what, primitive data type. Now understand this particular thing. I hope you understand this one. Okay, now what is the difference between these two statements, getting, what's the difference between these two statements? Both are having some internal implementation. Observe here, what is that means? Observe properly. within our JVM, getting in our JVM we are having n number of memory segmentations. Getting memory is getting divided into different parts, guys. Okay, observe here. So as part of that memory segmentation, you are having buffer area also. Getting buffered area, getting that buffer area will be used by our JVM for its performance improving things. Okay, now observe here. You are having two memories called as heap. Getting, you are having two memories like what? Heap memory and SCP, string constant pool area, which is buffer area for a string literals. Getting string literals. Observe here, observe this part. Because of this new keyword and constructor, here this object will get create at heap area. Getting, this object will get create at heap area. Getting, guys? And observe here, there is one small thing. Whenever JVM encounters or faces a particular string literal, wherever it is facing a string literal, it will create one object at buffer area. Getting, that's an internal implementation. Observe what it does. Whenever it encounters a particular statement having string literal, means it will create one object at buffer area called a string constant pool area. I will tell why this string constant pool area. Simple thing, simple trick. Okay, just to improve the performance of application, than that nothing. Okay, we will discuss about this string constant pool later. Okay, now what is that? Whenever it encounters a string literal at whatever the statement or instruction, it creates that literal as object data at buffer area. It creates that literal as an object data. Observe here, as an object data at which area? At the CP area. And its type will be as what? Object type. Object type is what? Once again string. Okay, a string only. Okay, done. Till here at this right operand side you have done good job. Now come to this point. This will be having one reference. Of course, even objects available at buffer area will have address, and also these objects having addresses at available at heap area. Both the objects are having address. Okay, both will be unique, different. Observe here, let it be 0x009. Let this address be 0x003. Now this will be having hash code, friends. Okay, hash code, let it be something which is generated by object class hash code method. Let it be this address approximate integer value is what? Our hash code. Let it be 1234, and let it be this one approximate value 7362. Okay, now this address and hash code approximate hexadecimal string value is our reference value. This address and hash code, any one of the thing will be considered and will be converted to approximate hexadecimal string value. Okay, so that will be the reference value. Let it be 9f, approximate, not an equivalent. If you get this one, if you do reverse conversion, you will get the address and hash codes, then there is no security. Observe here, if I convert this one to the equivalent thing, getting, and if I do reverse conversion, getting, then there is a scope to get this address, so we can get the location of data and we can modify the data. So that thing should not be done here. This is an approximate values. Okay, that's the internal implementation of our Java. Okay, now even this one will be having a reference which will be a different one. Let it be 36 A. Okay. Now this S variable will contain, this S variable will contain the reference value of which object, either this object or this object. Yes, very important. You have used a new keyword, so and also you have used a constructor. So this S variable always refers an object available at heap, meaning is this S variable will contain the reference value of an object available at heap. Okay, so now S equals to 9f. So 9f both are same, so that S is referring this object but not that object. Now one second, this object is not referring by any of the reference. It will be available like that as it is at memory. Okay, that is the meaning of this string S equal to new string literal. Mohan do. Whenever JVM encounters a particular string literal, blind it will go and it will create one string object with this literal as what? Data. Getting with that literal as what? Data. Now because of this entire statement, now it will create an object at heap because of a new keyword. Getting heap area is dynamic area. Getting dynamic, where you can increase the size and where you can decrease the size according to the requirement. Okay, now because of this new keyword, object created at heap area, and this S will contain or it will hold the reference value of an object created at heap area 9f. Getting, and this object reference will not hold by this S here because of new and string. Observe internal implementation. Now let's understand this one. Okay, now even at this statement, let's talk about SCP, string constant pool area, that is buffered area for string. Okay, now whenever, observe here, whenever JVM encounters a string literal, what it will do? It will create an object with that string literal as data. So first create that one, creating an object with a string literal. Getting, Mohan do. Getting, yes, done. It's of which type? A string. Does it contain any address? Yes, it will also have address. Let it be 0x 0x001. Let it be approximate integer value to this address as our hash code. Okay, let it be 171. Okay, now this address and hash code approximate value conversion to hexadecimal string is what? Our reference value. Getting, approximate address and string values in the form of hexadecimal string is what? Our reference value. Okay, let it be 171E. Okay, now observe here. It has encountered what? A string literal. So JVM created an object of type a string, and within that object data is what? Mohan do. That is this string literal. Okay, now here in this statement, do you have new keyword? Do you have any new keyword? Do you have any string constructor? No, you are not at all having. So no object is going to create at heap area. Getting, will not get created at heap area. No object at heap area. Getting, now this ES will contain the reference value of this object only. This S contains the reference value of this object only. Okay, so now yes will contain the reference. This S variable will get stored at stack. Okay, 171E based on the category. Getting? So based on the category, I mean which type of category variable it is, that is we are having instance variables, static variables and local variables. Okay, so based on that type it will get stored. Now s equals to what? 171E, 171E. So this s is referring this object. Okay, so because of that statement the object will get created at which area? At which area? At SCP area, and that literal will be as a data for an object. Okay, and now this yes will refer this SCP object only, no a new keyword and constructor. Getting? So no object will get created at heap area, only one object is creating at this statement, and because of this statement JVM encountered what? A string, a literal. So first created an object of type string with this literal as the data. Getting? And this object data will have address, hash code, reference value, and because of new keyword an object created at heap. Getting? With the same data. Getting? With the same data, this one will have unique address, hash code, reference value. Now this S will contain the reference value of an object which is created at heap area. Getting? This is the internal implementation of our string class objects. Getting? What we have understood as part of this session till now means, what is the number one? Does a string is user defined data type or primitive data type? Getting? So we have understood that string can act as user defined data type here. Getting? String s equals to what is that? String s equals to what is that, friends? New string within the collectives literal, string literal. So here it is acting as what? User defined data type. Here you are using a new keyword, and here you are using what? Here you are using constructor, and this one will get created at heap area, and constructor is available within the skeleton of a string. So S is what there? User defined data type. Okay, and now observe here. In this statement, S is what? A primitive data type variable. Why? I didn't use any new keyword and any constructor of a string class. Moreover, this object will get stored at buffer area but not at heap area. Getting? Even storage class is getting different. Getting? That is storage area, memory allocation is getting different from this statement to this statement. Getting? So what's the answer for this one? It can act as both user defined data type and primitive data type. Getting? So string can act as both user defined data type and primitive data type. Getting? So this is the analysis thing. Now what is the difference between this statement and this statement? If we write the string object creation in these two ways, what's the major difference? Simple thing, they are having some internal implementations for these two statements. Okay, number one, whenever JVM encounters a string literal, JVM will go and create a string object with a literal as the data. Getting? And this object will be unique, that is it will have unique address, unique hash code, and what is that? Even reference value also. So whenever it encounters a string literal within any statement, it will create that object at heap sorry, SCP area. Getting? So that object will have this literal as the data. Now because of new keyword and string constructor, there will be one more object at heap area with data as what? Once again this string literal only. This is the implementations, guys. Okay, observe here, two objects created within this because of this instruction. Now this S variable will contain the reference value of which variable? It will contain the reference value of an object related to heap area. Getting? Heap area. This is internal implementation. In this way Sun Microsystem implemented in this one. Okay, now whereas in this case what happens? First it encountered the string literal. So first go and create an object of type a string with data as what? This string literal. Yes, created, everything happened. Now do we have any new keyword here? And do we have any string constructor? No. You are not at all using any string class new keyword and string class constructor and new operator or keyword. So this in this statement JVM will not create any object at heap area. Okay, yes, done. Now this S will contain which object reference? Means only one object, this object reference only it will hold or contain. Okay, this is what we have learnt here. Okay, now we might be getting one doubt. What is that? Means if an object is not having any of the reference variable, getting? Nullifying. Of course, if an object is not having any reference through any reference variable, observe here, does this variable have any reference here? Any variable is referring this object like this? No, no object is referring. So this object is having no reference variable. When we can tell an object is having no reference variable means if this object reference value not available with any of other reference variable, then this object is having no reference variable. Getting? So here no reference variables, friends, like this. Okay, you are not having any reference variable containing the reference value of this object. So this object can be stated as what? Object having no reference variable. Now if this is the case, this object will be eligible for garbage collection if it is available at heap area. Getting? Observe here, if there is an object, getting? If there is an object having no reference variable, observe here, S1 of 999F. Now it is having a reference. If I take out this reference variable, does it have any reference variable? No. Now it is eligible for garbage collection. Finalizer thread will come and destroy this useless object. Okay, so this is not at all the case at the SCP area. Why means, observe here. Okay, why means, observe, simple point, observe. Finalizer thread which indicates garbage collector. Garbage collector don't have accessing rights at SCP area. Getting? So what is that? Garbage collector. Getting? Garbage collector doesn't have rights to access the objects at SCP area, even though the objects are not referring by any reference variable. Getting? Reference variable. Getting? Why? Getting? Why is the question? Simple thing, you will get the answer for this one in next session. Okay, there we will discuss about it in great detail. Okay, why means simple. here you will not create duplicate objects. This is creating by whom? This entire object is created by whom, friends? Observe here, whenever JVM encounters a statement which is a string literal, I mean if it encounters string literal, it will create a string object with that literal as data. Who is creating? JVM. So JVM is having some conditions whenever it creates objects at heap, I mean at SCP area. Okay, we will discuss. Okay, this is what we have learnt here. Okay, and garbage collector don't have any permissions to access an object at SCP area, even though object is not having any reference variable. That is, this object is not referring by any of the reference variable. Okay, now observe. Now observe, let's go and understand some other internal implementation of our string class. Okay,